Welcome and hello. This is a video lesson in EPA SWMM. And in this lesson, I'm going to be discussing viewing results, specifically the study map area, both before and after a simulation, as well as statistical analysis for after a simulation. All right, here we go. What I have on the screen here is the welcome screen. So welcome to SWMM. I'm going to start with my site runoff drainage project right here. You can access that welcome screen by going up to the help menu and welcome screen if you wanted to add a sample project and follow along. All right, so we're going to be talking about two things here. First, it's the map results and then statistical results after that. The map results here is the map study area that you see, and that works in tandem with the map browser here. So over in the left side panel, there's the project browser and the map browser. Go ahead and select the map browser, and then we have this side panel of controls, which let us dictate how we want to view the different subcatchments, nodes, and links, which are the different themes you're seeing here with these different drop downs. So keep in mind, I have not ran a simulation right now. This doesn't have any results, but I can still display certain data in the study map area. So for subcatchments, my themes are area, width, slope, percent imperviousness, lid usage. And then for nodes, all I can select is invert. And then for links, I have max depth, roughness, and slope. Now I'm going to run the simulation and you'll be able to see how we have more options in these drop downs for theme. So running the simulation, clicking OK, that's done. The simulation has been run. And now the options for subcatchments now include total precipitation, total evaporation, total infiltration, as well as dynamic data. So this is the total data, which is static, and the summation over the entire simulation. And then we have dynamic, like incremental time-specific data that will be changing, such as the instantaneous precipitation, snow depth, evaporation, infiltration, and so on. All right, nodes, originally all we had was invert, but now we have a bunch of other data right here, like maximum data, as well as the values down here, which are dynamic. And then for the links, now we have maximum flow, max velocity, and so on. And down below, we have flow, depth, velocity, volume. All right, let's go ahead and add some color to our map. For subcatchments, I'm going to select area. And then what you see here is a legend that popped up in the top left. We can move this legend around just by dragging it with the left mouse click button. And you can see that all of our subcatchments are below 25 acres in area. That's why they're all blue on the map. But I can go right click and then change the different values that are used to define the colors. I can type in a number, or I can just click on this auto scale button. If I click on auto scale, it recognizes the size of the values in the map itself and then creates numbers to sort of divvy up the different colors amongst the items, or I should say the objects. So when I click OK, now we have red right here. This is subcatchment S4. It happens to be the largest subcatchment at 6.79 acres. And it now qualifies for the red color because it's larger than 5.6. The yellow size here means that the subcatchment is between 4.2 acres and 5.6 acres. So that's true for subcatchment S1, S2, and S5. Now, when I hover over that particular object, I am getting a label that tells me the name of the object as well as that parameter, 4.55 acres in the case of subcatchment S1. If you don't see this on your screen, but you want to be able to see this label when you hover, go ahead and go up to the Tools menu and then Program Preferences, and make sure you have this checkbox for flyover map labeling checked. So if I uncheck it and then I want to, so if I hover over, it's not giving me that data that I saw before. I personally like this feature, so I'm going to go ahead and toggle it back on and OK. So this is true for not only subcatchments, but also nodes and links. So for nodes, let's go ahead and set the maximum depth. Now the nodes have color. In fact, I'm going to toggle off the subcatchments just so that the coloration of the nodes stands out a little bit more. The maximum depth here now has its own legend. And as before, we can right click on the legend if we want to modify it somehow. In addition to the auto scale button, we can also change the color ramp. This blue, cyan, green, yellow, red is the default color ramp, but there's lots of other options. Besides rainbow, there's pastel, there is red, so it sort of fades from white to red, orange, and so on. Here's the green one. If I click OK, and then I click OK, Now we have different shades of green, which range from, well, white, which is not green at all, to this sort of a dark green color. I can also reverse the order. So if I reverse the order and click OK, that's what that does. If I want to manually type the numbers in, I said I could do that here, but you can also manually change the color just by clicking on that individual color on the color ramp and then changing it and then clicking OK. I'm not going to change it though. And then the last thing to mention here is the frame checkbox that just adds or removes this frame around the legend itself. See, there's no frame right now. And I'll go ahead and add it back in. All right. I do like the frame though. Let's go ahead and take an example of the links. Here is the link data. This is referring to conduits. So maybe flow is probably a popular one. Now, what I've selected here for flow is a dynamic variable, which is going to change with each time step change of the simulation. So I can play back the animation. I'll talk about that in just a moment. And when I do, it will change the values of the links. So if I hover over a conduit now, conduit C5 at the first hour of the simulation has 0 flow. But we have this date picker and a time of day picker. So I could go to a different time of day, say, I believe maybe 35 minutes into the simulation, and all of the flow rates are now above 1 CFS. So if I hover over a conduit, we have 17 CFS, 9 CFS, 17 CFS. In this one, we have 9 CFS. So I on purposely chose the time of the storm with the highest flow rate. It's either 35 to 36 minutes, depending on that particular conduit. So now's a good time to talk about the playback animation. I'm going to reset this back to the very beginning of the day. Also, I can control the time of day using this slider bar as well as the date itself. Now, this simulation is taking place on January 1, 1998 for the first 6 hours of the day. So there's only one day. So the slider bar and the drop down for date don't really have any effect. But for the time of day, it should range from 1 minute all the way up to 6 hours. And here is the 6 hour mark. Now the 6 hour mark also has no flow anywhere, or it may have just a little bit of flow. Nope, no flow. So I'm going to go ahead and set this back to the beginning of the day. I can also just use the slider bar right here, which is probably a little bit easier than using the drop down. Below that, there is an elapsed time right here. So I can click up the elapsed time the same way I can just click over on the time of day. And as you can see, the colors in the conduits are changing, and that's because the storm is occurring and then the flow is filling up these conduits. So that's 17 minutes, 20 minutes, 25 minutes, 30 minutes, 35, 40, 45, 50, 55. That's 1 hour right there. Now the peak has stopped, but we still have a bunch of flows, but the flow should be dying down and the colors should be changing from red to yellow to green and then back to blue. So let me just manually continue here. That's an hour 10, hour 15, hour 20, hour 30, and then an hour 45, and then 2 hours. I'm going to click on the play button down here, and this is going to continue the animation, but I won't have to continue clicking. So there I hit play. It's 202, 205, 210 right there. And then as you can see that the flow rate through these conduits is decreasing as the colors change from green to cyan to that royal blue color. All right, so I'm going to hit stop on the animation, and then I'm going to drag the time of day back to the beginning of the simulation. This slider bar right down here below the animator buttons of play, stop, play back, and rewind is the animation speed. So the fastest animation speed is right here, and I'll go ahead and click play. Again, we're viewing the flow rate through the conduits, which is now at a peak, and then it starts to decrease over time. We can see this also in the flow hydrograph. This was covered in the previous lesson where I talk about looking at time series data. But if I look at, say, conduit C8, and then I click on the time series plot, conduit C8, boom, we have a peak flow of just over 18 CFS. And that peaks at about, 35, 36 minutes into the first hour. But then we have sort of a residual flow of about 1 CFS up into about 2 hours past the simulation. And then it just dies out about 2.5 hours, and then it's back down to 0. So we can have all three of these themes going at the same time. So for instance, subcatchment area, nodes could be maybe depth, and then the lengths, we'll just keep that at flow. Now we have 3 separate legends right here. I already talked about how to modify the legends by doing a right click. You can toggle on these legends and toggle off the legends. And then the time right here, which is the same time that we see in our time period frame, that's also considered a legend that can be toggled on and off. To toggle the legend off, for whatever reason you may not want to see it, just go up to View, Legends, and then they all have a check mark beside them right now. But say, for instance, I don't want to see this link flow legend. I'll just click on link, and then boom, it's gone. I can add it back in by going View, Legends, and Link. The legend is back in here. I can also remove legend by just doing a double left click. So these are all gone now. And then I can add them back, of course, by going up to View, Legends, and then checking them on. The time legend, just as the other legends are, is both mobile, and also I can double click to remove it and bring it back by going up to View, Legends, and Time. All right, the last part of the map display results that I want to demonstrate is exporting it. So if I wanted to save this particular image and bring it into a report, for instance, then I would click on File and then Export and then Map. Now I have three different options here for the types of files. First is the text file, which is a .map file. This is an ASCII-based EPA SWMM specific map format. So let's go ahead and save one of those. I'm just going to call it map and then save it to my desktop. Okay. So I have a map.map file right there. The next option here is file export map, and that is EMF, enhanced Windows meta file. This is sort of your typical image file that you'd use. So let's go ahead and do an example of that. I'm going to call it EMF and then save it to the desktop and click save. So we have an EMF.emf file right there. And then the last option is file, export, map, and that is a DXF file, drawing exchange file. This is Autodesk's DXF file format. I'm not going to do an example of this. I don't have any Autodesk products to open it up in, but just so you know, if you're using Autodesk and you wanted to export this data, the .dxf file is the way to go. I'm going to go ahead and open up these files real quick. Now the map.map file, this is just, like I said, a text-based map file where it's recording the coordinates of the different nodes, the different vertices, the polygons, subcatchment data, rain gauge, and so on. It's a very small file. In fact, let's see what it's saying on its properties. Yeah, just 11 kilobytes in size. Now the EMF file will be a larger file because it's more of a typical image file. Let's go ahead and check out that size. That is 7 megabytes. And what that looks like is, let's see, what is it going to open up in? Okay, so it opened up in Paint. This is our image. And let me go ahead and open it up just in a normal image viewer. Open with Urban View. Yeah, so here is the image right here. Something I could easily paste into a report if necessary. Once I get all the colors and animation in the background image, just as I want it. All right, well, that is it for viewing the results on a map in the study map area. The second part of this lesson, I want to talk about statistics. After a simulation has run, a statistics report can be generated for a given object or variable. So to do that, you'll go up to the report menu and then click on statistics. And then this is the dialog box for controlling what sort of statistic reports you want to see. You can also access this dialog box if you click on this button right here, which is create a statistics report. It's the big capital Sigma button. And then here is the same dialog box. The object categories we can select are either subcatchment node link or entire system. Let's go ahead and stick with link and pick on that same conduit that we were looking at before, which is C8. Now it happens to be selected because it's selected right here in the map. But if you wanted to select a different conduit, for instance, click that conduit in the map, click the plus button. Now it's C6, or you can just type it in. You don't have to use that selector tool. So let's go back to C8. The variable analyzed, this depends on the object category, but for links, the options for the variables we can analyze are flow, depth, velocity, volume, capacity, and TSS. So we'll just stick with flow rate for now. Event time period, I'm going to go with event dependent, which means I need to provide the event thresholds down below here. I'll talk about that in just a moment. The next field is statistic. So this is the mean that I'm looking for. My other options are peak, total duration, and inter-event time. These statistic value variables are dependent on the type of variable that we selected up here for flow. So for instance, if I had selected TSS, now we have some water quality statistics that we can select, like mean concentration, peak concentration, mean peak or total load. Okay. So just keep in mind that that's how that works. I'm going to put it back to flow for the variable analyzed. The event time period for event dependent, that means that the length of the time period is defined by the event data down here. These are the thresholds. So because I selected flow, it says flow right here. If I had selected depth, it'll say depth right here. So I'm going to, whatever you select here is what it's going to say here for the event threshold. Now let's take a look at that time series data once again for conduit C8. I'm going to select the conduit and then click on the time series data plot. I'm going to define an event as being a flow rate of greater than 0.5 CFS, which will occur probably right around here, maybe 20 minutes, 15 minutes into the simulation. And then that event will continue until a little bit after 2 hours into the simulation, maybe 2 hours and 10 minutes. So that event where I'm defining the event as being a CFS, a flow rate of greater than 0.5 CFS, should be a duration of about 2 hours, maybe a little bit less. So let me go ahead and just close that up and put in a flow rate of 0.5 hours. I can change this threshold to whatever I want. So maybe 1 CFS or 2 CFS or 5 CFS. So I'm going to say 0.5 CFS. This is the minimum value that must be exceeded for a time period to be included in an event. Event volume works in a similar way. This is the minimum flow volume or event volume in this case. A rainfall volume depends on which variable you select. That must be exceeded for a result to be counted as part of an event. I'm going to leave this at 0. Therefore, the flow rate of 0.5 CFS will sort of control what constitutes an event. And then the separation time here, this is in units of hours. It doesn't say hours right now, but it is hours. I'm going to set this at 6. So I'll just use the 6 that it was. This is the number of hours that must occur between the end of one event and the start of the next event. So if it's less than 6 hours, then it's going to be considered one single event. That gives the modeler and the person looking at these statistic results a way to sort of group events based on the separation time. All right, so with these values selected, I'm going to go ahead and click OK. And then here are my statistical results. What we have here in this dialog box is a number of tabs. So along the top, we have this summary tab. That's the first one. And then events, histogram, and frequency plot. In the summary tab, what we have at the top is the input data. So what you're seeing here is pretty much the same data that we saw on this dialog box that we filled out here, sort of like your input data. So the object we're looking at is link C8. We're looking at the flow rate. The threshold is 0.5 CFS. The separation time is 6 hours. Down below here, we have the summary data, meaning there's only one time period where the flow rate exceeds 0.5 CFS. It doesn't exceed 0.5 CFS and then go below 0.5 CFS. And then we have 6 or more hours of wait time, and then it exceeds 0.5 CFS again. In that situation, we'd have more than one event. But right now, we just have one event. The event frequency of 0.319, this refers to, it's basically 1.9 hours divided by 6, because I said the duration that event is taking place is just under 2 hours, and the total duration of the simulation is 6 hours. So I'm pretty sure that's how it's getting 0.319. If I increase that threshold to something above 0.5 CFS, like 1 CFS, for instance, then that event frequency would be less than 0.319. Down below here, the rest of the information is kind of trivial only because we only have one event. If we had multiple events, like 5, 10, 20, then it would give us the minimum and the maximum value of the events, not just the mean. And then we'd also have some information about standard deviation and skewness coefficient. All right, so maybe not the best example. The next tab over is the events tab. And again, this is only going to have one row because we only have one specific event. The duration in hours of that event was 1.9. During that flow rate, during that event, the mean flow was 3.584 CFS. And then we also have fields for exceedance, frequency, and return period. After that, we have 2 tabs for histogram and frequency plot. Again, this is not really the best example because there's only one event. So these 2 tabs would be better demonstrated if there was a different example with multiple events. All right, well, that is it for this lesson. What we talked about was viewing results in EPA SWMM, specifically the study area map, as well as the statistical analysis.